right, let's take a look at example 4.31. A chair of mass 12 kilograms is sitting on a horizontal floor. The floor is not frictionless. Okay, so there's friction. You push on the chair with a force of 40 newtons that is directed at an angle of 37 degrees below the horizontal, and the chair slides along the floor. Draw a clearly labeled free body diagram for the chair. All right, so whenever we draw our free body diagram, we start with a box. Now it's on a horizontal surface, so that's where I'm going to start. Now I'm going to draw the forces that are acting on it. So what forces are acting on it? Well, the easiest one to do is gravity. So gravity always acts from the center of the object straight down, mg. Then we have our force applied to the chair at an angle down. Now whenever I draw a force, even if it's a push force, I'm going to draw it on the opposite side. So my arrow always points away from that object. And so this is 40 newtons directed at 37 degrees below the horizontal. I like to draw my forces away from it. That's why I'm drawing it there. Now it is sitting on a surface, so there is a normal force. So I have a normal force pushing up from the ground. We can use this N to represent normal force. If you want to put a vector arrow over the top of it, that's fine. And then lastly, it's not frictionless, so there is friction acting on it. So we're going to put a force of friction. If you wanted to be specific, the force of friction is acting at the base here. I'm just going to draw it like that. Now that I have my free body diagram, we can start to create equations, but right now we just want to make sure that we can identify all of the forces acting on it and draw them on our picture. There we go.